Here's another type of inequality that we're going to graph. And of course you can always use your calculator to graph, but let's look at how we would do this without using the calculator. So the first thing I have to notice is that this is an absolute value function. So an absolute value function, I know, is going to make a graph that has a v either pointing up or a v pointing down when I'm graphing in two variables. Here I have a y variable and an x variable. So the easiest way to graph this is if I were to put this into vertex form. So let's think about that. Vertex form. Vertex form is y equals to a absolute value x minus h plus k. And we know where h, k is our vertex, and a is either a compression or a stretch. Okay? So this is almost in that form. I just need to get this 1 out of there, and I need to make it not a negative y. I need to make it a positive y. So the first thing I'm going to do is I'm going to subtract 1 to each side. So that gives me negative y is less than or equal to the absolute value of x plus 2 minus 1. So that may look like we're done, but we're not, because I want y, not negative y. So the easiest thing for me to do, I don't like to divide, I prefer to multiply. So I'm going to multiply everything on the left by negative 1 and everything on the right. Okay? So notice how I put that parentheses around everything. So the first thing I want to note here on our right side is we cannot multiply inside the absolute value. That absolute value is in jail, so we have to be careful about that. But I know a negative times a negative is a positive, so that gives me y is less than. If I multiply negative 1 times this absolute value, I'm going to have a negative absolute value of x plus 2. But then negative 1 times negative 1 is plus 1. That's the tricky part. Negative 1 times the absolute value, it cannot go in, so it stays on the outside. But I have to multiply all terms by negative, so negative 1 also gets multiplied to this negative 1 that's trailing here on the end. Okay, so what does that mean as far as our graph goes? Well, we've got to find the vertex. So we know looking from here, our vertex is going to be opposite of that, which is negative 2, and the same as that, which is 1. So those of you who remember when we did graphing with vertex form, that was the pattern that we saw. So I'm going to put in negative 2, and 1, which is right there. Okay? But I also have a reflection over the x-axis. So if we remember our parent function, let's just go over here and review our parent function. I'm going to write this in blue. Our parent function is y equals the absolute value of x. We know that our vertex is at 0, 0, and we know that our a value is 1. Here our a value is negative 1, so it's upside down. So if you remember your parent function, I'll do the parent function in orange. Parent function origin is here, up 1 over 1, up 1 over 1, up 1 over 1, and then the same on the mirror side, up 1 over 1, up 1 over 1, up 1 over 1. So we do a reflection, we're just going to do the opposite. We're going to start at our vertex for our point, negative 2, 1. We're going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And in here, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Okay? So, we're doing an inequality. This inequality happens to have an equal sign on the bottom. by the way, these points here will be in your calculator in your table. I'll show you that in a minute. Okay, so our absolute value is facing down, and it looks like that. Okay, so what do I need to do? I need it where y is less than or equal to. Well, the equals to has to do with our solid lines, but y is less than. So I could test a point somewhere and see if this is true. But we're going to test it using our calculator and using what I showed you in the previous example. So if I'm here at my y-axis, right here on my y-intercept, I'm looking for where y gets smaller. Well, doesn't y get smaller as we go this way? So y gets smaller as we go down. That means everything beneath gets shaded. So everything down here, in fact, it keeps going all the way down beyond the scope of the graph, everything underneath. So any point in there will satisfy this equation and make it so. Let's test it in our calculator. So let's take our calculator, turn it on. We're going to go to the y equals. I'm going to clear that. That's from our previous discussion. And I'm going to set that back to normal for now. Just a line. Okay, so in here I'm going to put in, I can't put in this, I have to put in this equation. So if you mess up, it's going to be a little tough, okay? You have to do the algebra to get it to where it says y and then whatever the inequality is and then the rest. So I'm going to put in negative absolute value. So I'm going to go to math, absolute values under numbers. Oops, sorry. Okay, I'm going to go, let me do that again because I didn't realize it was off the screen. Okay, oh, sorry. Okay, so let me clear that. So I'm going to go negative, but to put the absolute value in, I'm going to go math, number, absolute value, and I'm going to put in x plus 2, x plus 2. Then I have to make sure I get outside of that absolute value, and then I'm going to put in plus 1. Okay, so what am I looking for? I'm looking for y less than. So I'm going to go back over to that section where that little bar is. I'm going to go in there. I'm going to go down here, and I'm going to make it so that it's less than. That's on the bottom, so that has to be less than. Oops, sorry. That's on the top, so that has to be more than or greater than. So I want the less than, the one on the bottom. For those of you who have an older calculator, if you just go over to here and keep pushing enter, this will actually flap on and off, and it will change just like this. So I'm going to select that one, less than, and then I'm going to go to graph, and I'm going to see that it shaded the bottom just like I did here. Okay, so if we were to go to our table, second table, we see we have some points there. So I don't want all these decimals that are here, so I'm going to go ahead and I'm going to change my table set because it's starting every point. It's changing every 0.1. Let's start it at 0, and I want to change it every 1 because I don't like all those decimals. Okay, so here we go. So 0, negative 1. Well, here's 0, negative 1. 1, negative 2. Well, that's 1, negative 2. 2, negative 3. That's 2, negative 3. So you can see this is giving me all the points on the line. And in this case, those points would actually make this true because I have an equal sign in my inequality.